Thank you for being there with me. I'm glad to have you. Today I want us to look at how we can convert a galvanometer so that that same galvanometer can read voltage or can read a potential difference. Let's do it together. Assuming we have a galvanometer, we'll have it like this. This is a galvanometer written with G. Now we have it connected elsewhere. Now, if we want this galvanometer to read, and of course, galvanometer measures very low current. However, you can still convert it to measure voltage. Now, if you want to convert it, all we need is to get a very high resistance resistor, connect it in series with the galvanometer. So if you connect it in series with the galvanometer, it will now be able to measure voltage. So let's see how it goes. And that's very high resistor used in converting a galvanometer to a voltmeter is called a multiplier. So let us take it. It's a multiplier. So in other words, we can say that a multiplier is a very high resistance resistor connected in series with the galvanometer in order to convert the galvanometer to a voltmeter. So we have, this is our galvanometer. We can connect a resistor in series with it. Now remember, this resistor, I can use, let us use small letter r to represent this multiplier. Now there is a current flowing here. That current flowing through the galvanometer is current through the galvanometer, which is Ig, or you can say it is the maximum permissible current through the galvanometer. This same galvanometer has its own resistor. The resistance of the galvanometer is represented with letter Rg. Now, if you have it like this, automatically a joint will be formed here, because if we want to get the PD across the multiplier, we can have it as our V1. So V1 is the PD across this multiplier. Now we can still have another one here, which is V2. V2 is the PD across the galvanometer. Now, in all this, the total PD across the entire arrangement is V. So V is the entire multiplier in question, or sorry, they converted the voltmeter. V here is the converted voltmeter. Why this R here is the resistor that we use to convert this galvanometer in order to measure this our potential difference. Now from Ohm's law, we now have that PD across the multiplier. PD across the multiplier. PD across the multiplier is current. Remember, this is just a portion of a circuit. This is just a portion of a circuit. Now, our interest is just on this. This is the current. This current that is flowing into this section will flow into this one, because it's a series. Once it gets to this one, it will now move across to flow into this one. So PD across the multiplier is Ig multiplied by R, which is the multiplier. Now we also have that PD here, PD across the galvanometer. I'll write it as galv is equal to the same current flowing times Rg. So Ig multiplied by Rg. And of course, current across PD across the multiplier is V1, which is what I have written here. While the PD across the galvanometer is V2. Now, the PD or the voltmeter reading. Therefore, we can now have that the voltmeter reading is V1 plus V2. That is potential difference across the multiplier and the potential difference across the galvanometer, which is V1 and V2. In other words, if you add the two together, it will now give us V is this V, okay, the voltmeter reading V is equal, which is this V, is equal to V1 plus V2. So this V will now give us V1 is current through the galvanometer multiplied by the multiplier plus V2, which is IG multiplied by RG. Now in this case, something is common there. I is common. If you bring that I, which is common, we now have it as V is equal to IG into RG plus R. So this is our formula. This is the expression for calculating everything, any problem you want to solve based on conversion of galvanometer to anemometer. This formula is valid. So let us take one or two calculations before we conclude. Now we'll take the first one. The first one says a galvanometer of internal resistance 5 ohms. A galvanometer of internal resistance 5 ohms. That means the resistance of the galvanometer is 5 ohms. Gives a full scale deflection of the current 0.01 ampere. 0.01 ampere. Explain with the aid of a diagram how you would convert it to a voltmeter for reading up to 12 volts. Explain with the aid of a diagram how you would convert it to a voltmeter for reading up to 12 volts. That means V is 12 volts. In other words, this is the diagram. Now, since this is the diagram, we don't have any other need to draw another diagram. So we make use of this diagram. So we have, remember our formula says V is equal to IG into RG plus R, where V is the voltmeter reading. IG is current through the galvanometer, RG is resistance of the galvanometer, while small letter r is the multiplier. So we now have this. If we substitute, we have V is equal to, in place of IG, I will have, of course, sorry, this is the IG. I will have 0.01 into RG, resistance of the galvanometer, 5 ohms, plus the multiplier. Multiplier is what we are looking for. Remember, V is given to be 12, please. Now, if you have this, having substituted here, all we need to do is to multiply out, which will give us 12 is equal to 0.01 times 0 times 5 will give us 0.05 plus 0.01 R. At this point, we'll collect like time. This one will move over to here. We'll have 12 minus 0.05 is equal to 0.01 R, which will give us, if we do the apply our calculator, 12 minus 0.05 will give us 1195. Okay, sorry, 11.95 is equal to 0.01 R. Now make R the subject. R will give us 11.95 all over 0.01. Therefore, R will give us 1195 ohms. So, and remember the question says, explain how you will do the conversion. So how we do the conversion is that we connect a resistor of this value, very high resistor of 1195 ohms, connect it in series with the galvanometer. And once you do that, the voltmeter will now reach up to 12 volts. Okay, let us take another question. This question says, remember, galvanometer can also be referred to as a moving meter. A moving coil meter, please. It can be referred to as a moving coil meter. So let us take this one. This one says, a moving coil meter with an internal resistance of 100 ohms. With an internal resistance, that means Rg is 100 ohms. Has a full scale deflection when a current of 10 milliampere, which is what? Ig. When a current of 10 milliampere flows through it, what value of resistance would convert it to reach 10 volts at full scale deflection? What value of resistance will convert it to move? At least V is 10 volts. Now they want us to get R. Of course, it's still the same thing with what we have just solved. So we'll still look at this. So we have, from the formula, V is Ig into Rg plus R. Now V is 12 volts, with V is 10 volts. 10 equals I, which is, and of course, this one, we need to convert it. So Ig is 10 milliampere. And of course, 10 milliampere is something as 10 times 10 raised to the power minus 3 ampere, which will give us 0.001 ampere. No, it should give us 10, let us be sure, 10 divided by 1000, 0.01, please, 0.01 ampere. Now we have 0.01 into Rg. Rg is 100 plus R, which is the multiplier. We now have 10 equals 0.01 times 100 will give us 1 plus R. We now have, move this one here, it will give us, no, 0.01 times 100 will give us 1, okay? We are right. Will give us 1. Okay. 0.01 R will give us 0.01 R1 we have is as 0.01 R. Now collect like terms. 10 minus 1 will give us 0.01 R. Like R the subject, R will give us 9 over 0.01, which will give us 9 over 0.01 will give us 900 ohms. So this is a very high resistor as well. So in order to do this conversion, a resistance of this value, very high, 900 ohms, is connected in series with the galvanometer, and it will give us what we have. This is where we'll end the lesson today. Thank you for being there with me. Please, if you have not subscribed to this channel, do well to subscribe. But if this lesson was helpful to you, give it a thumbs up and then tell me there in the comment section. See you in my next video. Thank you very much.